Hi, welcome to the video about using the power rule shortcut. In this video we will define the power rule and also work out 3 examples of its use. So right here on the screen I have the power rule. If n is a constant, then the derivative of x to the nth power is equal to nx to the n minus 1 power. There's a link to another video on our site that proves this rule to you. Also, there is an activity where you found the derivative of various terms with coefficient 1 using the limit definition of the derivative. And hopefully when you're doing that, you saw that there was a pattern. It turns out that this pattern is always true. Let's check some examples out. Okay, here we go. So I have some examples from interactmath.com here, and the first one is to find the derivative of x to the 10th power. So let me just write that out here. F of x equals x to the 10th power. Okay, so the power rule says to take the derivative of this, all you have to do is just take this exponent and that becomes a coefficient. So let's start again. Let's see. F prime of x, right, the derivative of the function, is equal to, and this exponent comes down, becomes a coefficient, 10x, and then we subtract 1 from the exponent. Minus 1. And we can simplify this a little bit by just writing that this is equal to 10x to the 9th power. And that's it. That's the using of the power rule. Let's try it out. 10x to the 9th power. Well done. Let's check out another example. So, same idea here. Find dy dx for y equals x to the negative 10th power. And here, let me just erase all this. Delete. Okay, and let's write this one now. So now we want to find dy dx, Leibniz notation now, for y equals x to the negative 10th power. And it doesn't matter that it's a negative exponent, it's the same exact rule that works. So let's do that. Dy dx, we'll use Leibniz notation this time, equals, and this exponent here is going to come down and become the coefficient. So negative 10 x to the negative 10 minus 1. Same exact thing, even with negative exponents. The power rule still works. And then we can simplify this to negative 10 x to the negative 11th power. Negative 10 minus 1 is negative 11. And there you go. That is the derivative of y with respect to x. Let's check our answer. Negative 10 x up to the negative 11th power. Good job. Okay, let's try just one more example using the power rule. So here we have a function y equals x up to the 0.35 power, excuse me. Still the power rule. It's to the same exact thing. So let me just erase this again now, all this work here. And let's write this one now. So we have y equals x to the 0.35 power. And even with decimals, exponents, this still works. So dy dx, the derivative of y with respect to x, is going to be equal to, and this exponent here is going to come down and become the coefficient, 0.35 x, and then we're just going to subtract 1 from our exponent, so 0.35 minus 1. And then just to simplify this really quickly, that's just going to be 0.35 x to the negative 0.65. Right? 0.35 minus 1 is negative 0.65. And here, let's check our answer out. Up to the negative 0.65. And there we go. So that's it for the power rule. All you got to do, if you have a term with a coefficient of 1, the exponent comes down and becomes the new coefficient. Leave the x alone and just subtract 1 from the original exponent. That's the new exponent. And that's it.